Welcome to Chapter 9 of the Geosystems Core series, and in this chapter we will be covering weathering and mass movement. The topics that follow the headings in your readings are weathering and landforms, physical and chemical weathering, karst topography, mass movement, and we'll conclude with types of mass movements. Here are the concept questions that are presented with each chapter. Remember that these are good questions that could appear on your exams as short answer essay questions, and the idea is that you should be able to put together related facts into a paragraph to answer each of these questions. Thinking about weathering and how it prepares landforms for erosion, what unique landforms result when water erodes limestone, and how does mass movement alter landforms. We're going to talk about features that are caused by weathering, like arches, sinkholes, domes, and karst towers. It's important to understand that geomorphology is a study that investigates the origin, evolution, and distribution of surface landforms, things that we see above ground. And in previous chapters, we've studied plate tectonics movements and things that occur below what we see. Now we're going to focus on what we can see. Once landforms are uplifted, denudation processes wear away or rearrange them. Weathering will break down rocks on or just below the surface, and there is also mass movement that occurs because of the movement of the earth, often related to the plate tectonics we've studied before. And erosion is a driving force of many changes in our physical landscape. And we'll talk more about it in Chapter 10, but let's make sure we understand it's the transport of materials primarily by wind, water, ice, waves, and gravity. So there's a force that's moving materials from one place on Earth to another. When we think about a slope, it's an incline, and some are stable and some are unstable. They vary with their rock structure or composition, and they also vary according to the climate that they're in. So we did study climate versus weather extensively, and we know that climate refers to the amount of water in the atmosphere, and also temperature and weather effects. So weathering will loosen material. The slope angle, raindrops, freezing and thawing, moving animals, and winds all promote erosion. And sediments are smaller pieces of rocks or rock particles, and a maximum incline that a slope can remain at rest before gravity begins to pull it down is called the angle of repose. A slope is stable if the strength exceeds gravity and denudation and you don't have any or very little movement. It is unstable if the strength does not exceed gravity and denudation, and then you get movement. Here's a diagram showing you these different forces. So in A, we have the 4 different forces that are acting in opposite directions of each other. Up and down, we have push of the surface up, and we have degree of cohesion down, and that is related to the weight of the rock. And going to the left of the diagram, we have frictional resistance. So friction is when 2 objects are coming in contact with each other, and the forward movement of that object is hindered because of that friction. And then down to the right, we can see that if the object is moving in this direction, it means that the rock exceeds the geomorphic threshold and is moving. And then at the bottom, we have the principal elements or the parts of a slope. So starting at the top, we have soil processes. Below that, we have a free face or a front of the slope, and then there's a debris slope where it's not quite as steep as the free face. And then at the bottom, we see the fine materials, and in this case, it's a riverine system with trees and water flowing through it. Also depicted here are the different phases where physical and chemical weathering is being the primary force on the free face. transportation is occurring at the top of the debris slope, and then deposition is occurring at the bottom of the debris slope. This is a diagram showing you the angle of repose, comparing 35-degree angle versus a 45-degree angle. And so those angular pebbles need a higher degree angle before they'll start moving than the fine sand. And then at the bottom is an even smaller angle, a very, very fine sand in a desert sand dune. A weathering process occurs when the bedrock, which is parent rock, forms, and in this bedrock, regolith and soil will develop. And regolith is a layer of unconsolidated rocky material. It combines with other weathered rock to form the parent material from which soil evolves. So here's an example of a mountainous area, and you can see that there's physical weathering in the upper canyon. We can see evidence of that by the shapes and the different structures that we can actually see with our eyes, and the bedrock will loosen and eventually start moving down slope. The vegetation will add an element of chemical weathering as those plants are taking nutrients out of the actual rocks themselves. And then going further down in the image, gravity is pulling this regolith downward, and you can actually see where it looks like there's sediment showering down that mountain, fanning out at the bottom. And then the very bottom of this, the farmers can till the soil particles that remain behind. So this is an important process for plants to get nutrients out of the materials that are available to them. So nutrients would be transported from the very tops of the mountains up following this series of steps that I've just talked about. And then they could end up in the soil at the bottom in the crop areas and used for agricultural production. So the factors that influence weathering, the rock composition and structure or jointing. A joint is defined as fractures in the rock that occur without displacement. Climate will also affect the weathering process. Subsurface water is part of the water table that occurs below the surface. The slope orientation, is it facing the sun, and how is it affected by winds and exposure? Organic processes, this has to do with growing plants, and also animals can affect weathering. And then time. And so over time, weathering will continue to occur, and it is cumulative or additive. Differential weathering is where we have inconsistencies in rock composition, depressions, and cracks, and this exposes the rock to various weathering processes. Not all rock weathers the same way. So you can see here that we have on the left is some organic influence, and we have decaying vegetation, and there is a depiction here of the regolith that was mentioned earlier, and we see the bedrock. On the right would be a picture of a tree root that is impacting and actually growing down through a surface rock. Rock is broken and disintegrated without chemical alteration. And so there's a frost action or freeze-thaw action in lower temperatures, and repeated freezing expands the water, and then the thawing contracts the water. And this repeated movement, expanding and then contracting, will actually split and eventually break rocks apart. So here's an example of what this would look like, a real-world image below and then an artist's rendition above. You can see that when the water freezes in between those rocks, those blue arrows are showing you that it's expanding, and the rocks will push away from each other. And then when the water melts, you're left with cracks or ridges in the rock, which you can clearly see in the shale outcrop below. You can see some evidence of physical weathering on these stones and on the sidewalk on which the man is walking. And so physical weathering affects a lot of man-made structures as well. Here's an example of a very significant crack which is going from left to right, compared to smaller cracks, which are going from top to bottom in the same rock. And so you can see that over time, the action of water will make that crack larger and larger. There's also salt crystal growth. Dry weather draws moisture to the surface, and as that water evaporates, the mineral salts are dissolved and they're left behind, and they form crystals. And this is defined as crystallization. So you can see in this example here on the left, we've got dark streaks, desert varnish, and this happens when bacteria oxidizes clay and other particles that are attached to the rock surface, and that's why we get all of that variation in color that you can see here. And then on the right is showing you the water and impervious rock layer, how it concentrated the weathering process and formed out that niche where the cliff dwellings were built. With a pressure release jointing, layer after layer of rock peels off in curved slabs or plates. Exfoliation process can form an exfoliation dome. So you can see here evidence of exfoliation. And so if you follow down the line of people and look over to the right of that, there appear to be large segments of that rock, and this over to the left it smooths out, and then as you look below the people, that smooths out as well. And this is an example of exfoliation. With hydration, this means that we have a chemical breakdown in combination with water, and there's very little chemical change. Water does become part of the chemical composition, and hydrolysis is a term which means water loving, or water breaking. Lysis is to break, and this is when minerals react with water. So you can see here examples of minerals on the side of this mountain, and that is an example of hydrolysis. We can also have hydration in addition to hydrolysis, and hydration is the addition of water, not just the breaking of water like hydrolysis, and this can lead to spheroidal weathering. So if we were to consider the artist diagram first, we can see that we start with something that is cube-like in shape, and then as weathering is happening, it is impacting the corners faster than it is the flat surfaces, and so the cube gets a softened or rounded appearance in the second step, and then finally it is very rounded in the final step. And so the real world example on the left from Mexico's Sierra de Juarez, it is showing the rocks in various rounded formations. And if you look closely, you can see that there are some very curved and rounded areas in that rock pile. Oxidation is when certain metallic elements combine with oxygen. We can commonly see this as rusting, and it does traditionally create that red or rust-colored appearance in rocks and minerals, and a lot of man-made objects are prone to rusting, and we're very familiar with that. We see it in cars and in metal buildings and all different types of metal objects. Carbonation is when water vapor dissolves carbon dioxide and you get a resultant carbonic acid. And when the water and acid pool together over time, you will get solution pits. So you can see here that these pits are formed they're much deeper than the surrounding rock area, and it is created by that combination of the carbon dioxide and water into that carbonic acid, which wears away that particular part of the rock quicker than the other flat surfaces, and that's why you get those depressions or pits. So this is also related to acid rain, and with increasing pollution, especially in cities with a lot of cars and large populations, There is a great deal of acid rain that falls when rain interacts with pollution from automobiles and industrial complexes. And this carbonic acid is wearing down some of the great historical structures, statues, buildings, and monuments that man has erected around the world. So now we're going to talk about weathering and erosion caused by groundwater, and this creates underworld caverns. And the formation occurs because limestone that contains 80% or more calcium carbonate is present in a lot of the world's landscapes. There are complex joint patterns in otherwise impermeable limestone. There is a zone containing air, and that must exist in the soil in order for these caverns to form. And the vegetation cover is required to supply the organic acids. So, organic means living, and the acids in this process come from the vegetation. This map is showing you the major karst regions of the world in a dark purple, and then the lighter purple are approximate form and extent of limestone outcrops and bedrock. You can see that there are quite a lot of areas, mostly in the southeastern U.S., that have karst, and there are karst topography locations found all around the world. So some features of a karst landscape would be sinkholes and towers. A sinkhole is a circular depression. These can collapse in on themselves. And a tower would be a deeply jointed, thick limestone bed that rises up and looks like a tower. And these are found primarily in the humid tropics. Here's an example of a sinkhole. So when the city engineers built these streets and buildings, they were not considering the danger of this sinkhole and the potential for this much of a collapse to occur. And so here are some of those towers. Again, very humid areas can have these towers. Caverns are caves that form just beneath the water table. The dripstones form as water containing dissolved minerals slowly drips from the ceilings. If these formations come from the ceiling, they're called stalactites. If they come from the ground, they're called stalagmites. And if you are a person or a scientist who studies caves, you will practice the art of speleology, and you would be a speleologist if you were studying caves. And so here is a diver studying a cave system in Dos Ojos, Mexico. And above, the artist has drawn what it would look like, including the land features that we can see above. And so the sinkhole is right above a rock fall, and the artist has drawn in there some stalagmites, and then over to the right is a column stretches from the ceiling to the floor, and then we have the stalactites coming from the ceiling. And there is a representation of a rock fall, which is where the rocks would have fallen through the sinkhole, as well as a drip curtain where those minerals that are dripping down with the water form and harden and produce that pattern. If we want to think about movement of surface material that is caused by gravity, we need to consider the role of slopes. So remember that the angle of repose is the maximum angle that can occur before materials start sliding, and it varies. If you have heavier materials like pebbles and rocks, they can be at a steeper angle before they'll start sliding, whereas fine, smaller sand grains only need a small angle of repose before they'll start sliding. And that makes sense because you would think that the lighter, smaller material is going to slide easier than the heavier rock or pebble material. The gravity is the driving force, and it is downward of the slope, and the resisting force is the strength of the slope material. So you can see here that there is looks to be a shaved off or a much lighter area on the side of this mountain, and that there are several larger rocks and boulders at the bottom of this feature. And so you can see the effects of gravity here have caused erosion and some landslides, which have led to this pattern. The presence of water can trigger mass movements, and soil types like clay, shale, and mudstones will readily absorb water. That makes them very heavy and very prone to sliding in a mass movement event. They're weaker because they get inundated or soaked with that water. So you can see here the dotted line is showing you an area of a recent mass movement, and the vegetation is starting to grow back, but you can definitely see a difference in the surrounding vegetations, and then there's the soil or the dirt is revealed. And if you follow on down the side of that mountain, you can see where that side of the hill just gave way and slid very, very quickly. And so this soil was inundated over time, and then just gave loose very suddenly and slid quickly. So the thick, healthy vegetation will help prevent that. But you can see in the middle of the image over to the right that it looks like part of that mountain was bare. And so if the vegetation dies or is grazed down by animals, it can lead to bare soil, and that is more susceptible to getting soaked by water. So mass movement is a natural hazard, so people living downslope can be in a very dangerous situation. Landslides and mudslides do kill people. And you can see again another area of a slide near Lake Ceres, and the area of the slide is outlined with that red dotted line. And they are very dangerous. They can be unpredictable, and not always occurring after a rain event. It can be gravity and movement that causes this mass sliding. Okay, and we can look and see here our images before and after. So on the left we have Oso before the mudslide, and then on the right you can see that dramatic landslide scarp. And so this landslide was moving at 40 miles an hour, and you can see the some of the destruction that occurred in that bottom image. A scarp is a steep curved slope marking where the landslide began. So when a failure point is reached, this is called a geomorphic threshold, and there's 4 classes of mass movements: fall, slide, flow, and creep. A fall involves only rock, but a small amount of soil and plant debris can come with it. Slides are usually composed of moist soil. A flow, which is shown in C here, are much larger in volume than a fall or a slide, and they have significant amounts of vegetation, rock, and soil. And then finally, creep is a persistent and gradual or slow downward movement of the soil. With a fall, we would consider those to be falls and avalanches. Rock fall is simply a rock that falls. A debris avalanche picks up and carries material with it as it goes. It's a mass of falling and tumbling rock, soil, and other material. It can be tree trunks that have fallen down, buildings, large boulders, rocks, and soil. Again, some more examples showing you that this is obviously mass movement, and you can see that pattern, if you can envision the rock breaking free and then sliding down and piling up at the bottom of the mountain, but it's definitely showing that pattern of erosion and mass movement. A slide, with a landslide, there are large amounts of material falling simultaneously. Translation slide is movement along a flat surface. It's roughly parallel to the angle of the slope. And rotational slides move along a concave surface. So you can see here that this is the extent of the landslide, and so the red line is outlining the area affected, and you can see how far that sediment and material extended at the bottom of the mountain. So here's an example showing you that breaking off and the movement that's depicted in the bottom. You can see the trees are uprooted, and it was a sudden movement that then left behind this cliff. Here's a glide plane, and you can see that there are small tension cracks. Again, a cliff is left behind. It is not broken up as much as the last slide. With a flow, when moisture content is high, we can get earth flows and mud flows. So you can see this is the bottom of a river system, and the tremendous amount of mud and runoff was no doubt caused by either one or a series of rain events that loosened up material very quickly and then deposited it, as you see in this photo. A creep is persistent and gradual mass movement. It's slower, and this happens with freeze-thaw cycles, dry-wet cycles, daily temperature changes, and grazing livestock. And so the creep is depicted here. If you look at A, particularly the leaning poles, and so those would be telephone poles that were built, and because the soil and the ground underneath is slowly creeping, they start to lean over time, as does the leaning fence in this image. And even the tree is showing response to this slow creep with the curved pattern of growing. And that's an indication that there is creep occurring below the surface. The box in the lower left is just showing you that this happens with the expansion of freezing. And then when the water melts, it retracts back, and then it's more susceptible to gravity. On the right is an image of statues on Easter Island, and they are slowly moving downhill where they are located, and this is because of soil creep. Humans can disturb slopes and induce a mass movement. Scarification is when large excavations lead to unstable mine debris. This is an example of the extraction of minerals from the earth, and this can lead to a lot of instability and create mass movement. This is an example of mountaintop removal, both in an image and a map depiction. And the mountaintop removal is a way to extract minerals, and it is basically showing you large-scale scarification. And it's shaving off or just, bulldozing off the top of mountains, and it leaves behind this pattern, which without the vegetation rooting down those areas, it is more susceptible to mass movement. So in summary, there are many different types of movements. This is an example on the left of a blue hole, and it is a karst sinkhole near Belize, and it's called the Great Blue Hole. And then on the right is some weathering that is happening on a Grand Buddha in southern China, that acid rain and acidification. And then below is some damage from a massive landslide. So humans are intrigued and very vulnerable to mass movements around the world. And that's it for this chapter. Thank you.